decided to do some upgrades to my Creality CR10S. Welcome to Hack a Week. I love this printer, straight up. First, let me say that. As it sits, great printer. It's been nothing but awesome. It's real easy to work with. I usually get the bed level dialed in and I do 24 prints flawlessly. It's great. Hats off to Creality for making a really awesome product. As things are wearing a little bit, I'm noticing a couple of things going on with some of my prints, lumps and bumps, things being a little offset on the Z-axis. It staggers around a bit. There's some unevenness. Not sure if it's a slicer issue or if it's the printer, but at any rate, the CR10S uses a bowden tube feed system for the filament. That's kind of good in a sense that you don't have a lot of mass moving back and forth across here, shaking things out of alignment. But if you print slow, you can negate quite a bit of that, I suppose, with, you know, inertia and all that. I digress. Anyway, I picked up a direct drive kit that should just go directly on here. There's a little extension cable. It looks like it's a pretty straightforward install. It was $100, so let's check it out. The from the factory setup is with a bowden tube, and then the stepper motor over here is what feeds the filament. So what we're doing is moving this stepper motor over to here, along with some of the components from here, like the hot end, etc. And it's all going to then mount on here and move back and forth. This will be eliminated. I will have a section of bowden tube, maybe about that long, between the dual drive gears that will be pushing filament through the hot end. First thing we need to do is print a benchy. So I did. I printed one as the printer sets now. We'll print one later and compare the two. I don't think I'm going to see huge differences, but just want to try out this product, see how it works. So it's not a bad looking benchy there. Pretty decent. Not a bad print at all. We'll see how it looks after the change. You can see some of the lumpy bumpies that I'm talking about. Let's see if I can point them out. Right there, there. Get it just right. See the little shadows? The lumpy bumpies. They randomly show up. We'll see if it's related to mechanical or is it slicer, because I've had it happen in a couple of different slicers. So anyway, let's take a look at that package. So I just bought this. This is not paid advertising or anything. Just decided to check out a direct drive for the CR10S. This popped up. Looked good from Micro Swiss. And made in USA, it says. Wow, I was going to say probably made in China. But this is the thing that was attractive. It's the dual gear setup. So one of these gears is driven by the stepper motor and there's spring tension on the other one. And so not only is it an idler gear, it's coupled to the drive mechanism of the first gear. So they stay in sync on each side. Technically, you'd never have any slippage once you get the spring tension set right. Let's open this up and see what's inside. Of course, a QR code, or just type that in with a keyboard. Goodies. Oh, these are beautifully machined parts. I gotta say, pretty freaking awesome. So I'm not big on unboxings, like one thing at a time. It's like, is that it? Is that it? Is it empty? Yes. All right. Now let's just kind of lay it out here real quick. And then what I'm gonna do is kind of jump online, look for a tutorial. I know there's one out there somewhere. I'm not out to do a tutorial. I'm out to just kind of record me putting this on my printer, printing another benchy, and see how it performs. Just realized I had to heat the hot end up so I could retract the filament before I go any further. Having some trouble removing the bowden tube. It's just not releasing from the hot end. Hot end's hot too, by the way, but still not wanting to come loose. So anyway, cutting it. Doesn't matter. onto the stepper motor. Okay. Bye-bye. And gear removal. All this, bye-bye. New hardware. Stepper motor. 3 screws provided in the package. We're going to put one here, here, and here. Not there. We're going to leave that one blank. There's 3 holes that are countersunk. Pretty self-explanatory where they go. This is the tension lever and where the other gear resides. And the machining on this stuff is just the bomb. So nicely done. Stepper motor gear. Shove a piece of filament in there, I'm thinking. Move it back and forth a few times. Let that find where it wants to be and then tighten it up. Oh yes, and do make sure that you line up your set screw with the flat side of the shaft of the stepper motor. Thank you very much. We got this unbelievably beautiful machined tension adjustment screw. It's flat on here where it goes through that section so it can't twist, and then it has a thumb nut. And they say the best place to start is with the stud flush with the thumb nut. That's our starting point. My goodness, the machine work. Well done, yes. Bit of hot end assembly now. The titanium thermal brake. Awesome. Nice little hunk of titanium. And we're just going to flip this over and put the nozzle in. 0.4 millimeter. Okay. And now we can get the heater block assembly on. Look at that, it looks like a little motorcycle engine. Small piece of tubing needs to be inserted into here with the bevel. See this bevel? There's a bevel. It's pointy. That needs to be facing up, and as if it was going to nestle in between 2 gears, which is what it's going to do. Alright, that tube is going to go right up through here. Easier said than done. Until it butts up against everything right there, and assume that that's the length it's supposed to be. Yep, there it is. They line right up nicely. Mounted. We need to disconnect the old hot end. Okay, let's get the temperature sensor hooked up and the hot end. end installed. Damn, did that just break? That temperature sensor? Son of a bee. Ouch. That puts a little damper on things. Yeah, that little temperature sensor is gone. Broken. Gotta find a new one. Okay, so on hold till I get one of those. However, we can continue and move the project forward because there's still things to do. I forgot also I have this nice silicone sleeve that goes over the hot end. Tell you what we can also do to move the project forward. We can install our new filament guide over here. This one's going to be good fun. So here's a pretty cool part. Here's the adapter for what used to be the feed motor. Now that feed motor is mounted down here. So we have a plug. There's an extension plug that I can wire tie right there. Now we can install the bowden tube that goes from here to here. Nothing's pushing over here. This is just a feed tube. It's just to guide it to the hot end. So what I need to do is insert this far enough where it's past this slot, because then there's an E-clip that goes on there and holds it in place. Okay, it looks like that's down far enough. Let's see if we can get this E-clip to cooperate. Already lost it. E-clips are great, but I gotta buy the tool. There's a tool. My lead mechanic at my shop has the tool. It's awesome. It holds it for you. Ninjas that sucker right in there. Cabling. So now that we have that bowden tube there as an anchor point, we can actually do some nice cable routing here. So here we are a few days later. I've got a thermistor installed in here, and we're ready to continue with putting all of this together. So we've got to get the hot end installed and the thermistor installed. I'm going to tackle that thermistor first. That's pesky. Right, so we're going to get this thermistor into this tiny hole in the aluminum. Okay. That looks good. And now we're going to tighten that screw up just enough to hold the wires and the thermistor in place. Okay, now we'll tighten up the two Allen screws that hold in the heater. It's a bit tight with the wiring and the fan here, but I think we're going to make it. Also rather tricky to get this Allen bolt started. There we go. One more time with the wire ties. Give myself a little slack there. Down here, about like that. Alright. So this is what's up next. We got to do a little changing, a little calibration and stuff like that. In the starting G-code, we need to replace all of what is there on the printer settings with this bit of G-code. So I'm going to go ahead and select all of this and copy it. Next up, extruder steps need to be calibrated. 130 steps per millimeter. Alright, I'm using Marlin 1.1.7, so we're going to go to control, oops, whoop, yeah, there we go, motion, and steps, and E steps, oops, I went Z, I want to get out of there, E steps, did it again, I hate that knob thing, I hate it, there we go, let's go, 130, was that what it was? Alright, I'm using Marlin 1.1.7, so we're going to go to control, oops, whoop, yeah, there we go, motion, and steps, and E steps, oops, I went Z, I want to get out of there, E steps, did it again, I hate that knob thing, I hate it, there we go, let's go, 130, was that what it was? So 130. Do 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 do. Boom 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 boom. 130. Done. I suppose I could manually lower the Z and just double check that the end stop switch is gonna do its thing before something crashes into the bed. But it looks like it was engineered to be an exact, yeah, it's just a little below that actually right now. Glad I checked that. Click, click, okay, there we go, I like that. I can adjust the rest now with a bed leveling routine. Alright, let's load up some filament and try printing a benchy. Everything's up to temp. Let's do a little extrusion and see what we get. 36 millimeters. Let's watch for the goop to come out of the schnozzle. There we go, it's pooing a little now. So my method of choice, been working for me great for years with ABS and other things, mostly ABS. Good old Aquanet, extra super hold cheap hairspray. Okay, let's get something printing here from the SD card. Benchy. Looking like a good first layer. Little Benchy. Benchy's done. Break them off. Let's peel away all that bottom stuff and we'll compare them to the one from the other extruder. There we go. The one on the left is with the Bowden tube. The other one is with the new direct drive. The real tell is going to be the lumpy bumpies. You can see them on the hull there. Little zits. I was getting all kinds of zits. Am I still getting zits? There's less zits. That's good news. There's a few less zits on that hull than on this one. We'll see. I'll get playing with it and see what's up. As far as stuff up on the wheelhouse, let's take a look at that. This is Bowden tube print. This is direct drive print. Is there any huge difference, really, that you can see? I don't know. Anyway, time will tell. We'll do some prints and see what really happens with this thing. Let's take a look at a V2 nose cone that I did. It's got these little bumps inside on the bayonet connectors and a hole appeared. I think that might have to do with the retraction, which I did not have set on this file to what they recommend. I have retraction big time on the file that printed this. Other than that, there's the Z seam. Hello. I can live with that. That's not bad. I can sand that out real easy. This is what I was getting before it got this bad. At the Z seam, it was just getting worse and worse. So, very odd. I don't know. Could have had to do with the feed, possibly. Maybe it had something to do. Maybe it had something. It had something. But anyway, this looks very nice. And I want to print more and get that retraction dialed down a little and see what we get. Well, it's happily printing away and making much better looking prints. Definitely a lot better. One more time on this nose cone section, how smooth it is. It's a beautiful thing. Of course, the Z-seam is in, a couple of places staggered, but easily sandable, but no more pimples and zits and yuck. Beautiful. All right, well worth it. So I say yes to the Micro Swiss direct drive extruder for the CR10S. Well worth the $100. It's doing such a great job. I mean, I can't deny it. It's awesome. It just seems to make a little more sense. It's direct drive, less play. The Bowden tube's got its pluses and minuses, but there's a lot of slack in that tube, and I think over time that's kind of what added up to all the mess I had going on, because it's working great now, so I'm sold. So if you get one of these, let me know how it works out in the comments below. I'll put a link down there to where you can get one. I got this one on Amazon. So there we go. I guess that's about a wrap on this one then. I've got a printer that's printing much better now for a $100 more investment, and I'm happy. Till next time.